Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fizuddin bin Muhammad Johari. Okay, I will present about overview. The depletion of fossil fuels and global warming have accelerated the shift to alternative energy sources like solar and wind, which are abundant and cost-effective but unpredictable due to weather dispensi. Hybrid solar-wind systems address this challenge by enhancing efficiency, reliability, and reducing storage needs, making them suitable for both and grid-connected applications. Designing such systems is complex, requiring optimal sizing and advanced techniques like probabilistic models and AI. This paper examines advancements in hybrid systems and highlights opportunities for further research. Okay, for problem statement, the growing energy demand, depletion of fossil fuels, and environmental concerns have made it essential to shift to renewable energy sources like solar, PV, and wind. However, standalone PV or wind systems face challenges like unpredictable energy generation due to weather change, leading to unreliable power supply and high storage costs. Combining PV and wind into a hybrid system can address these issues by using the strength of both sources. However, designing such a system is complex, requiring efficient resource use, cost optimization, and reliable performance under varying conditions. This creates the need of a simple, efficient, and affordable PV-1 hybrid energy system with advanced control and optimization techniques. Okay, we got three objectives. First one is to design and simulate a hybrid renewable energy system combining photovoltaic and wind energy to ensure reliable and sustainable power generation for varying environmental conditions. Second, to implement maximum power point tracking techniques to optimize energy extraction and enhance the efficiency of the hybrid system under fluctuating weather conditions. Third, to evaluate and analyze the system performance through simulation to demonstrate its capability to balance energy demand, improve load management, and minimize costs for remote and off-grid applications.
Assalamualaikum, my name is Muhammad Arif bin Ali Hari. I will continue for the next part. Okay, this is the block diagram of the hybrid energy system. This system uses solar panel as the main source of energy. Okay, for the first block is PV module. This represents a photovoltaic module that generates electricity from solar energy. Okay, go to the next block is DC to DC converter. This component converts the direct current output from the PV module to a different DC voltage level. For the second energy resources is wind energy. This represents a wind energy source such as wind turbine that generates electricity. Then go to the next block is AC to DC converter. This component converts the direct current from the wind energy source to alternating current. Okay, these two energy will be combined and generate power. And then go to the inverter. The inverter takes the DC input and convert it to AC power that can be used by the load. And then it will supply to the consumer. Okay, if the renewable sources are not available, a battery will be used. This battery will store excess energy generated and provide power when needed. Okay, this is the flowchart of the project. This flowchart outlines the process of a hybrid renewable energy system that utilizes both solar and wind power sources. The system begins by checking the availability of solar irradiance. If solar irradiance is present, the PV module generates electricity. If not, the system moves to the wind energy source and check if the wind speed is sufficient. If the wind speed is adequate, the wind turbine generates electricity. The electricity generated from the PV module and wind turbine is then conditioned using various electrical components such as DC to DC converter and inverter to ensure the appropriate voltage level and conversion to AC power. An energy integration step combines the power from both sources, and the system then check if the stored energy in the battery is sufficient. If not, The wind power is used to charge the battery. Finally, the conditional electricity is supplied to the load, which represents the device or equipment that require power. This hybrid system seamlessly integrates both solar and wind energy sources, with the battery storage serving as a backup to provide a reliable and efficient renewable energy solution.
Assalamualaikum, my name is Ahmad Shafiq and I will present about hybrid system, especially for purpose of PV and wind turbine for hybrid system. So this is the example of schematic of our project for PV and wind turbine. Okay, the proposed hybrid energy system consists of a PV array and induction generator driven wind energy conversion system meeting a common load. The PV system consists of PV arrays and corresponding DC to AC converter modules. Generally, according to the sunlight conditions, the maximum power point tracking control mode is adopted for PV system, which aims to maximum utilization of solar energy. A bridge inverter is used to connect the load to the hybrid system. Batteries are used to store the power when the power production exceeds the demand. The supply from the battery is needed during peak hours when power demand is higher than the production. Okay, so now I will present about modeling of various renewable energy system. There are 3 points for modeling, which is the first one is model of solar PV cell, the second one is DC-DC boost converter circuit, and the last one is cascaded 3-stage inverter. For the first one, model of solar PV cell, the PV system consists of PV arrays and corresponding DC-AC converter modules. When exposed to sunlight, photons which have energy greater than the bandgap energy of the semiconductor are absorbed and create some electron hole pair proportional to the incident radiation. Okay, for the second, DC-DC boost converter circuit. It is a most efficient topology which ensures good efficiency along with low cost. DC-DC boost converter is connected next to full wave bridge rectifier to raise the voltage of diode rectifier. From figure above, a capacitor C1 is connected across the rectifier to lessen the variation the rectified AC output voltage waveform from the bridge. Okay. The model of the boost converter is needed to simulate and analyze the behavior. The input and output voltage of the boost converter under an ideal condition can be written as Vin equal to Vout times 1 minus D, where Vin is the input voltage, Vout is the output voltage, and D is duty cycle. Okay, for the last one is cascaded 3-stage inverter. From figure above, it shows the FS of a cascaded H bridge inverter utilizing 2-3 level cells. The B and C phases are identical to the FS. The H bridge inverter is designed according to the voltage levels.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imam bin Makari and I will continue the presentation of energy source and performance of hybrid system. A hybrid system consists of 1.5 megawatt and 150 WP solar PV system is simulated. The parameter of the wind turbine and solar PV system are given in table 3 and table 4. The subsystem of the wind and solar PV system are given in figure 5 and 10 respectively. The load is connected to the hybrid system through an inverter with the rating of 1.3 MVA. PWM with carry frequency of 1 kHz is given across the gate circuit of the H-bridge inverter. Is how the developed MATLAB simulation model of hybrid renewable energy system. First, the system is simulated with the wind and solar alone, and the performance of the individual generator are evaluated. Next, the performance of the hybrid system is evaluated under different load conditions. In this case, both wind and solar PV system are used to meet the demand. DC-DC boost converter is combined with multi-level inverter to get the output voltage of 230 volt. Figure 14 show the hybrid system with wind turbine model, synchronous generator model, power converter, PV system, and control block. The capacitor value of the interface rectifier is 6000 mAh. The resistance load of the hybrid system is 500 ohm. The hybrid system is operated with one at 40 ms and solar PV system with irradiance levels such as a C 0.8. This hybrid renewable energy system was combined solar and wind power has a significant positive impact on both society and the environment. By integrating these two renewable sources, the system can provide a more stable and reliable electricity supply even when weather conditions fluctuate. The environmental benefits are substantial. The system reduces greenhouse gas emission and air pollution by replacing fossil fuel with clean, renewable energy. It also maximizes energy extraction and efficiency through the use of advanced components like MPPT, controller, and DC-DC converter, ensuring optimal resource utilization. Socially, this system enables access to electricity in remote or off-grid areas, promoting social equity and supporting economic activities. The reliable energy supply reduces the need of expensive and limited storage solution, making it a cost-effective alternative. The modular design of the system, as shown in the MATLAB Simulink model, allows for scalability to different applications, from rural electrification to supplementing grid-based system. The figure demonstrates the system's ability to adapt to changing environmental conditions such as varying wind speed and solar irradiance level, while maintaining the energy balance through battery integration. In summary, this hybrid PV wind renewable energy system represent a significant technology advancement that not only address environmental challenge but also exchange human well-being by providing reliable and accessible electricity, ultimately contributing to the achievement of global sustainability goal. In the conclusion, this project combines solar and wind energy to create a reliable and sustainability power system. The system uses both solar PV module and wind turbine to generate electricity. When one source is not available, the other can still produce power. The electricity from these two sources then processed using converter to make it usable. The system also has a battery storage unit. This battery helps when the solar or wind energy is not enough. It store energy and provide power when needed, ensuring a continuous supply. The results show that using both solar and wind energy is more efficient and reliable than just using one. For example, the battery could handle high demand period when solar or wind energy was low. The inverter also made sure the power supply to the load was stable and usable. Combining multiple renewable energy sources, as done in this project, is an important step toward a more sustainability energy system. In the future, improvement like better energy storage or real-time monitoring could make a system even better. Overall, this project provides a practical and environmental friendly solution to address the energy challenge and support the goal of using more renewable energy.